Hi, my name is Daniel, and I'm in geology section on geology section 3 in geology 111. Today, I'll be demonstrating the tectonic plates with three things: white crackers, round crackers or orange crackers, and a piece of bread. The bread will represent our asthenosphere mantle and upper crust mantle and lower crust mantle. And then our crackers will represent our oceanic crust. And then our orange crackers will represent our continental crust. So the three types of plate boundaries are convergent, divergent, and transform. All of these boundaries have different features that are associated with them. But to describe what a boundary is our planet, I guess our piece of bread, and if you were to, make this into a 3D thing, is really a soft, squishy kind of thing. The mantle also is a softer, it's a fluid, more motionless thing. And it is not exactly solid, but it's not exactly a liquid either. It has a viscosity to it. And what rides on top of it is a crust, and different types of crust exist. Our ocean crust is thin and is made of mostly basalt rocks, and is much newer than our continental crust, which is also much thicker, which allows it to rise on the sand. As you can see, there's two cheeses as opposed to one cheese. When the continents converge or whatever, when there's convergence between two tectonic plates, which are the plates that kind of like, if you were to imagine a puzzle over the earth or whatever, that would be what the plates are. There would be the puzzle pieces, or in this case, this would be the Cheez-Its and how one Cheez-It covers part of it and then the other Cheez-It covers part of it. When they converge, as in they're going towards the same direction, what will happen is if it is oceanic crust and then the other is a continental crust, one of the plates will subduct under it, so it will go underneath. As you can see here, it goes underneath, and then it goes underneath, which will cause on the continental crust mountains to rise, but will cause also the oceanic crust to subduct, which then will continue being subducted as the slab pull mechanism pulls it down, because it is on the edge a colder and more denser plate, which means that it has decreased buoyancy than compared to the continental crust. It will also heat up underneath and cause things like volcanic activity on this continental crust in opposition to mountains. It can also cause trenches on this side. So for example, if you look at this, as our plate is diverging or converging or not into there, it is like there is a trench as it goes into the thing right here. Because, it is being this or not is solid pressure. It will also sometimes form accretionary discs or accretionary material or whatever as it gets kind of scraped onto it, onto the other crust. On the other hand, we also have other crusts like divergent crust. So for example, if we're in the middle of the ocean, we would have our two oceanic crust, and they would diverge and pull away from each other. This would cause a mid-ridge to form. If it was to happen in land also, it would cause a basin, which would be what begins to separate continents together, which is why we've had the deformation of four supercontinents. It can cause the asthenosphere to rise. So as it pulls away, the asthenosphere rises and then it cools off because it's exposed to the ocean, the surface or not, which then causes it to harden into more new continental crust or continental oceanic crust. And finally, we have our transform, which can also happen because of divergence or not, which is essentially when instead of our crusts going away from each other or towards each other, they go beside each other. So for example, we have a movement like this. This can occur in fault zones, which are essentially or fault, it can cause like fault zones, whatever, or be near fault zones, whatnot, but it isn't actually a fault zone itself, which is when essentially the same crust cracks, but it doesn't actually slide against each other. If for it to be a transform fault, it has to go transverse, not oblique to each other, and that one can cause like earthquakes or seismic activity, and it can it's commonly present in places like, for example, California near the Carolina, Queen Charlotte's fault. Also to mention, there are some other features, like, for example, for example, Himalayan mountains would be a convergence because it's also two continental crusts or whatever. So because both of the crusts are buoyant and cannot be subducted, they kind of like push themselves up, like so. And that concludes some of the features and the demonstration of the different types of plate boundaries.